we have spent this whole chapter, this whole unit, looking at graphs of trig functions. Now let's look at why that's really helpful. So we're going to look at a Ferris wheel. Suppose you and your friend are the last two people seated on the Ferris wheel. So you just sat down, you're right here. Once the ride begins, the wheel moves at a constant speed, and it takes 36 seconds to go all the way around the ride and come back to where you started. So at 0 seconds, when the ride starts, how high above the ground are we? Well, we're 5 feet. At what height are you at 9, 18, and 27 seconds? Well, remember, it takes 36 seconds to make one full revolution, so we'd be at the top at 18 seconds. So 9 seconds would be here, and 27 seconds would be over here. So at 9 seconds, we're halfway across the Ferris wheel, and it's 40 feet in diameter. So we'd be 25 feet, because of the 5 feet here and then 20 here. 18 would be all the way up to the top, so 45 feet. And then we'd be back to 25 feet. At what height are you at 126 seconds? Well, let's think about that. If I took 126 and divided by my 36, which is my period, how long it takes me to go around, 126 divided by 36, I'd get 3.5. So that's 3.5 revolutions. So 1, 2, 3.5, I'd land at the top. What about in 3 minutes? Well, it's 60 seconds each minute, so that's 180 divided by 36. And I get 5 revolutions, so I'd be back where I started. What's the amplitude of this function? Well, sometimes it's helpful to think about the graph. Okay, so if I think about this graph, let's see, so 5, 10, 15, 20, 25, 30, 35, 40, 45. Here's 45. And 9, 18, 27, 36, and then it would keep going and going. So at time 0, we're at 5. Then we're at 25, 10, 15, 20, 25. And then we get all the way up to the top, and then we come back, and then we come back to where we started. So that would be kind of a curve like this, and then it would keep going. Now the period is going to be half the distance between the max and the min. So we're at a maximum at the top of the ride, 45, minus 5. So our amplitude would be 20. The midline is right in between. So halfway between 45 and 20 and 5, 45 and 5. So that would be at 25. Oh, when we're at the halfway around the ride. The period is 36 seconds. Write a trigonometric function for our ride. Now we're starting at a minimum. So that means it's going to be a cosine, and also it's going to be negative. The amplitude is 20. And now I just need to figure out the b, what comes in front of our x. So your period equals 2 pi divided by b. So 36 equals 2 pi divided by b. If I solve for b, I get b equals 2 pi divided by 36. So that's pi over 18 x or t or whatever you want to put. But we also shifted up, so plus 25. Now I had a spot for the graph here. I'm okay with us just doing that. All right. So this one suggests looking at the graph on the calculator, but I'm going to talk about how we can do this without. All right, so we have our equation for the velocity of airflow during a respiratory cycle from the beginning of one breath to the beginning of the next. So the time for one full cycle, that would be our period. Well, our period equals 2 pi divided by b. So our b in this case is pi over 3. Well, if I'm dividing by a fraction, that's the same as multiplying by the reciprocal. Oh, so it's every 6 seconds. Well, how many cycles would we have in a minute? How many cycles would we go through in 60 seconds? We go through 10 cycles. The model is for a person at rest. What would change if somebody were exercising? Well, they'd be taking in more air, so the amplitude would increase. They'd be breathing faster, so the periods would be smaller, and we'd have more cycles per minute. That's actually an increase in frequency is what that would be. All right. Eve is on a swing thinking about Trig. She realized that her height above the ground, it's modeled by this. How high is she after 1 minute? And so T is in seconds. We're trying to find out where she's at after 60 seconds. So you could either put the equation in your calculator and actually look at the graph, or you could just type in adding 60 in there, and I get that she's 8 off the ground. And her range of heights, so let's think. 5 is the midline, right? And the amplitude is 3. So she's going up 3 to 8, and then down 3 to 2. So she's going from 2 to 8.